Hey Calc students, how's it going? Today we're going to be working on 10.4, polar coordinates and polar graphs. Before I begin, hopefully things are going well. We're going to probably take most of the week on 10.4, maybe a little bit of 10.5. Next week 10.5 a little bit, and then study for our chapter 10 test. We're going to skip chapter 10.6. And after that's our final, and Lord willing, we'll finish a little early. So I want to cover 10.6, but I'm just gonna go ahead and waive it, and yeah, and there you go. Merry Christmas. All right, let's get started. Here's a polar point, 8 comma pi over 2. Plot it, and it's like, yay, it's a point. Okay, so it's 8 units out. Okay, and pi over 2 units, so 90 degrees. Doesn't look as cool. But if I bring up the graph in polar mode, and I've got that going on, if I did zoom 6 like normal, it looks like an ellipse. And but if I hit zoom 5 and squares it up, it makes it look like the circle that it is. Now we need to take and put this in. It also asks us to take and find the rectangular equations or the polar equations for this. Okay, so let me pause a second. All right, these are our bread and butter equations here. In x equals r cosine theta, y equals r sine theta in polar mode, and switching back to rectangular, tangent equals y over x, and then we've got this x squared plus this equals this, the circle equation. Alright, so all I have to do is just plug in where they belong. So radius is r, and theta is pi over 2. Plug that in. Cosine of pi over 2 is 0, and then sine of pi over 2 is 1 times 8. And then my x comma y point is 0 comma 8. Here we go, next one. Alright, so this next one's a little trickier. We start out at -4, and we want to get the point, and we also want to get the point in rectangular. So I'm going to hit trace, and notice as soon as I hit trace, it starts me off here at -4. -4, 0 degrees, and then 0 on the y. And if I go left, I want to go left, and it's like it won't let me. If I start going this way, notice it gets positive. The positive values get more positive. We're traveling counterclockwise, okay? But I want to go to -3 pi over 4, but that's the other direction. So we start here. That's what makes this more difficult, is we start here. And I want to go in the negative. I want to go negative, and I can't. So I have to change my window and note, oh, the pi is that. So I'm going to just go ahead and put -pi, okay, and hit graph, and then now hit trace. I start out there. Actually, it starts out here, but if I go all the way here, okay, I'm at -4, going this way. All right, look at my degrees, negative, and -pi over 4 is going to be right about there. So we're going to end up forming a rectangle here in the first quadrant because we started here and went this direction. Okay, so I drew that, from here to there is -pi over 2, from there to there is -pi over 4, so total distance -3 pi over 4. But if we went positive, we'd have pi over 4. So we actually could have two values for this, or two directions, excuse me. How do we get rectangular? Plug the points into our x and y equations. Both turn out to be 2 radical 2 and 2 radical 2, or you could do decimal approximate. So x and y, there's my point. 2 radical 2, 2 radical 2 in rectangular. Okay, next problem. Alright, I did want to work number 7, but I'm going to just go ahead and use the value for 3. It's the same thing. So 7 asks, use your graphing calculator and use the rectangular conversion. So it's under angle. Okay, so first off, I want to show you that if I do this, it becomes 2.828, which is the same as 2 radical 2. Okay, so I've shown that there. Okay, let me show the steps though again. So, hit second angle. I want to scroll down to polar to rectangle and x, and then -4. Use your comma key. I like to make sure I always use parentheses. Alright, and then hit enter. Whoops, I must put too many parentheses. Yes, I did. Okay, and there we go. And then if you did the same thing with the the y. It would turn out to be the same. There we go. Okay, so polar to rectangular in the x, polar to rectangular in the y. Okay, all right, let's move on. Okay, so we know r squared equals x squared plus y squared. Okay, so I'm just going to substitute r into there, and okay, so I wrote it this way to have, because I'm set it equal to 0, because I want to get into rectangular mode. All right, so far so good. Now we've got to get it all in terms of x and y's, and we've got this theta thing going on here. Okay, you remember from earlier, x equals this, y equals that, and so if I take a shortcut here, I can see, or I could kind of go x equals, let's see, 3 sine theta times cosine theta, and y equals 3 sine theta times sine theta. Alright, I don't need this one, and I'll show you. But this one is 3 sine squared theta. Okay, that's my y for this problem. Okay, hopefully you can see that I can convert. I can use the fact that I can separate numbers and call that this. And so this is y. So this just becomes 3y equals x squared plus y squared. And so the equation that we are looking for is this. Okay. So so polar mode to rectangular mode. Okay. So it's a circle. Y term. We could find that to get the center. We know the x coordinate would be 0. And we can find the y. It's going to be some ugly number here. All right. So let's continue. Okay, so our last one is number 63, and we are tasked with finding tangent lines. So this one, and we want to find the slopes, the tangent lines here, here, and here. Okay, so we know that slope is dy dx, and let me set this one up. Okay, so point 1, point 2, point 3, we all want to know the tangent lines of this one of them is a horizontal, so we know that's going to be 0. So, but we're going to prove it taking rectangular here, and we're going to convert that here, putting in our x value, r multiplied by the cosine theta, r multiplied by the sine of theta, carrying out that division. Now, we want to take dy dx of this, dy, and the derivative of this. So, ooh, this is going to be, yeah. Okay, so we want the derivative dy dx, but in order dy dx is going to be the derivative of y with respect to theta divided by the derivative of x with respect to theta. So this is going to have to, we're going to have to remember our chain rule here with these. Okay, so I'll work those out. Okay, so taking the derivative, this one's a little bit trickier because we'll start with the y. So 2 times this, we're going to derivative the outside multiplied by the derivative of the inside. So 2 multiplied by the derivative of sine is cosine, plus derivative of the outside, 6 sine squared theta, multiplied by the derivative of the inside. Derivative of sine is cosine. Okay, the other one, now going to the x, derivative of the first term, negative 2 sine theta, derivative of the second term. I showed that down here. We did this, we did this like first semester. 3 multiplied by, and then we have to use the addition rule here, and then this simplifies down to that. You can take a look there. Okay, so up in the numerator, I factored out a 2 cosine theta. Okay, and then the denominator, I'm still debating here. I'm debating whether to have it in cosine or sine, because the denominator is pretty ugly here. I'm going to simplify this to try to get it a little bit not as messy, so that way when I start plugging in values it might be a little bit easier. But you probably could just start right there as well. But I'm going to go ahead and simplify this slightly. You could just plug it in, but it gets really messy with these terms here. It may not look, but I'm rambling here, but I want to simplify it because I know what the cosine and sines of these are going to be. So, okay, what a mess here, but numerator here, and then I showed the work over here, converting sine squared theta to 1 minus cosine squared theta, doing the algebra, boom, putting it there. Doesn't matter, you could have left it like that as well. Okay. Now, point 1, just taking this and this, pretty much we're just plugging in the theta in each of the point 1s, finding their slopes. As from the diagram, we could see that point 1 and point 2 are horizontal lines, so their slope should be. So the cosine of pi over 2 is 0, so both of these would be 0. This would not be 0 here, but it'd be 0 over multiplication, so the numerator would be 0. We don't have division by 0, so we don't even have to work any of these others out. As long as we don't have division by 0, numerator is going to be 0, and we have a term in the denominator that's not 0. So same thing happened in from point number 2. Cosine of, was it negative pi over 2? No, positive pi over 2. Or 3 pi over 2, excuse me, that's a 3. 3 pi over 2, and then the cosine of 3 pi over 2 is 0 as well. And then we have 0 multiplied by a quantity, we get 0 in the numerator, we won't have 0 in the denominator, so again, 0 is the slope. Finally, the last one, the cosine of pi is negative 1, so in the numerator, and the sine of pi is 0, so in the numerator we have negative 2, and then the sine of this is negative 1 squared, so it would be positive 6 here. This would be 0 minus 3, so 6 minus 3 would be positive 3. So the slope is negative 2/3. Alright, so if we graph this, okay, looks like this. Alright, and then I wanted to prove it graphically, so second calculate, I want to find dy dx here, and then I want to scroll to the point negative 2, and then I hit enter, and it turns out that the slope at this, if the slope were here, this tangent line, if I were to create a tangent line right here that intersects at negative 2 along the graph, it would be negative 0.6, which is negative 2/3, which is the same as that. Okay, so that ends our broadcast. I'll post the homework. That's all I've got. So may the Lord bless you and keep you. All right.